Okay, folks, today we're going to be doing a lesson on how to make or how to write ionic formulas. Um, so first we're just going to take some notes on metals and nonmetals and what happens with their electrons. So remember that metals donate electrons. And so one question that you might have is that when a metal donates its electrons, where do those electrons go? Well, those electrons are given to a nonmetal. So a metal is only going to donate its electrons if there's a nonmetal around for it to donate those electrons to. Similarly, you might have the opposite question. When a nonmetal accepts its electrons, where do those electrons come from? Again, those electrons come from a metal. So a nonmetal is only going to be able to accept electrons if there's a metal around to donate those electrons to it. And so remember that metal ions are positive, right? Because when you lose electrons, you form a positive ion. And that nonmetal ions are negative, right? Because when you accept electrons, you become a negative ion. Those positive metal ions and those negative nonmetal ions, they're attracted to one another. And the reason why they're attracted is because they have opposite charges. So whenever you have two things with opposite charges, they're always going to be attracted to each other. It's kind of like two magnets being attracted to each other, right? Like the north end of one magnet being attracted to the south end of another magnet. They're opposites, and those opposites attract. Okay, so let's go through some examples. What we're going to be doing for examples today is drawing Lewis dot diagrams and determining the formula of the ionic compound. So before we do that, I'm just going to show you some models. And you don't not have to write this down, so don't write this down. So we're going to start off with the ionic compound sodium chloride. So we've got sodium here. Draw a sodium atom, or I have drawn a sodium atom on the screen. Remember, it's got one valence electron. And then here we've got a chlorine 35 atom, and it's got 1, 2, 3, 4, 5, 6, 7 valence electrons. Okay, so our sodium atom is going to donate its electron to the chlorine atom. Right? So the sodium atom is going to donate its electron, so it gets rid of it. So you can see we don't have the electron here anymore in this picture. So that its outer orbital is empty. This whole outer orbital is empty. Right? And that makes the atom more stable, so that's why it donates the electron. So then similarly, the chlorine atom accepts that electron, right? So we can see in the new picture now, we've got an extra electron with this chlorine atom, so that its outer orbital is full. And so this becomes an Na plus ion, right? Remember, metals form positive ions, and that's because it got rid of one electron. And this forms a Cl minus ion. That's because this chlorine atom accepted an electron. When you get an extra electron, you'll form a negative 1 charge. And then again, because these two atoms have opposite charges, they're attracted to each other, right? The ions are attracted to one another because they have opposite charges. And so we ended up with an NaCl molecule, right? That compound forms because those two ions are attracted to one another. Okay, so we're going to do a similar sort of thing here, right? We already know what our final answer is going to be, NaCl. But we're going to show how we develop this formula using Lewis dot diagrams, right? So first thing we're going to do is we're going to draw the Lewis dot diagram for sodium, Na, and we'll put a little box around it. This is something that I didn't teach when I was doing Lewis dot diagrams, so I'm hoping to do a little bit of reteaching on how to do Lewis dot diagrams right now. I think a lot of you are really struggling with how you're supposed to organize the electrons around the atoms, and so I'm going to do a little bit of reteaching on that right now. What you should really think of is the atom has a box around it. I think that'll help you with how to organize the electrons. Okay, so let's take a look at sodium on the periodic table. It's right here. You can see it's the first element in its row. And so for that reason, sodium is going to have one valence electron. Okay, now let's take a look at chlorine. And again, we're going to put a box around it. Chlorine is right here. It's the 1, 2, 3, 4, 5, 6, 7th element in its row. So we're going to put 7 valence electrons around it. Okay, so here's 1, 2, 3, 4, 5, 6, 7. Now, I want to go back real quick here. When you're doing this, each side should get 1 electron before any side gets 2. So let's just go through that one more time. This side gets 1, this side gets 1, this side gets 1, this side gets 1. So we're at 4. Remember, we're trying to get up to 7. Now you can start giving sides 2 electrons. We'll give this side 1 electron, this side 1 electron, this side 1 electron. Okay, and now we're up to 7. So both sides have the right number of electrons right now. So that's your first step, is you're going to draw the Lewis dot diagrams. All right, then you're going to go ahead and give the electron, donate this electron over here. So then when we redraw it, it'll look like this, with this 1 electron having migrated over here. Right? There's only 1 sodium atom, there's only 1 chlorine atom, so then we write the formula as NaCl. Okay, now let's do it with calcium oxide. Okay, so we have Ca. Let's take a look at it in the periodic table. It's the second one in its row, so we're going to give it 1, 2 valence electrons. Notice that I didn't group them together, right? That's because each side gets 1 electron before any side gets 2. Right? Next up, we're going to go oxygen, right, for the oxide part. So oxygen. Oxygen is right here. It's the 1st, 2nd, 3rd, 4th, 5th, 6th element in the row. So we're going to give it 6 valence electrons. So that's 1, 2, 3, 4, 5, 6. And remember, no side got 2 electrons before any side got 1 electron. So we gave each side 1 electron before any side got 2. Okay, and then now we're going to move the electrons over. So this first electron is going to move over here. Right? Calcium is going to donate electrons so that it has an empty outer orbital. And then the second electron is going to move over here. Oxygen is going to accept those so that it has a full outer orbital. So we can see calcium, the outer orbital is empty. Oxygen, the outer orbital is full. Okay, since calcium donated 2 electrons, it would have a +2 charge. Since oxygen accepted 2 electrons, it would have a -2 charge. But when we write our formula, we see there's only 1 calcium and 1 oxygen ion, so it's going to be CaO. Okay, let's move on to the next example. We've got magnesium fluoride. So we're going to look up magnesium on the periodic table. Draw it right here, Mg with the box around it. Mg's right here. It's the 1st, 2nd one in its row. So just like calcium, it's going to have 1, 2 valence electrons. Next, we'll look up fluoride, fluorine. So again, F with the box around it. Fluorine's right here. It has 1, 2, 3, 4, 5, 6, 7 valence electrons. So we're going to give it 7. Now remember, when you draw these, you go 1, 2, 3, 4, 5, 6, 7. Right? And so then what's going to happen is, since magnesium is the metal and it wants to have an empty outer orbital, it's going to donate 1 electron. It's going to donate an electron here. But what about this other electron? Where can it go? It can't give it to this fluorine atom because this fluorine atom would already have a full valence shell, right? Already have 8 electrons in its outermost orbital. So where's this other electron going to go? Well, what we're going to do is we're going to draw another Lewis dot diagram of fluorine over here. So it should look pretty identical to this one over here. And it's 1, 2, 3, 4, 5, 6, 7 valence electrons. And now this electron is going to get donated to this fluorine over here. So I drew it in a different color because it's going to a different atom. And so what does that final picture look like? Well, we have that first blue dot moved over here. Second blue dot moved over here. Right? We can see this fluorine's got a full valence shell, so it's happy. Magnesium has an empty valence shell. And then this fluorine atom right here has a full orbital, so it's happy. Okay, and so then how do we write our formula? Well, it's got one magnesium ion and two fluorine ions. So the way we'll write it is MgF2, since there's two fluorines. And again, the reason why this atom had to have two fluorines is because we had to have one spot for this electron to go and one spot for this electron to go. All right. Okay, so up next we're going to do potassium phosphide. Okay, so potassium, remember that's K. We're just going to put a box around it. Phosphide stands for phosphorus. Oh, sorry. So then how many electrons do we give it? Well, K is the first atom in its row, so it's going to get one valence electron. Okay, so next we're going to do phosphide. Remember that stands for phosphorus. Draw a phosphorus atom right here, and we're going to give it, since phosphorus is the 1, 2, 3, 4, 5th element in its row, I'm going to give it 5 valence electrons. So when we draw this out, 1, 2, 3, 4, 5. Right? Each side gets 1 before any side gets 2. Okay, and so then, again, potassium is the metal, so it's going to donate its electron. Right? But then, so then potassium is going to be happy because it has an empty outermost shell, valence orbital. But this phosphorus, right now, it would only have 1, 2, 3, 4, 5 plus the 1 potassium electron would be 6 electrons. It wants to get up to 8 so that it has a full valence shell. So it's going to need an electron here and an electron here. So we're going to add another potassium. Right? And this potassium is going to donate its electron right here. Right? But we still have one more spot where this could accept an electron. So we'll add one more potassium. Donate that electron over here. And so then our final picture looks like this. We can see that our phosphorus is full with electrons, 1, 2, 3, 4, 5, 6, 7, 8. And 3 of those electrons, these 3 blue ones, were donated from potassium ions. And the potassiums are all stable because they all have empty valence orbitals. This orbital's empty, this orbital's empty, this orbital's empty. And so then when we write our formula, we have 1, 2, 3 potassiums, K3, and 1 phosphorus. So then we'll write the phosphorus over here. So the formula for potassium phosphide would be K3P. Okay, and so then we have one last page of examples here. We're going to start off here with aluminum sulfide. I've already written the chemical symbol for aluminum and put a box around it. Let's take a look at the periodic table. Aluminum is the first, second, third element in its row. And so we're going to give it 1, 2, 3 valence electrons. And then we'll add a sulfur. Sulfur is the first, second, third, fourth, fifth, sixth element in its row. So we're going to give it 6 valence electrons. Okay? Remember that the metal always donates to the non-metal. So we'll donate 1 electron here. And then we'll donate this electron over here. But now sulfur's full. It can't take any more electrons. But aluminum still has 1 more electron to give. So again, just like before, we're going to fix this by adding another sulfur ion. So we'll draw another Lewis dot diagram for sulfur over here. Okay, then aluminum can donate its last electron right here. But now this sulfur atom isn't full. So how do we fix that? Well, now we've got to draw another aluminum with 3 dots around it. 1, 2, 3. And then this aluminum can donate one of its electrons over here. But now this sulfur atom's full. So now how do we fix the problem of these remaining 2 electrons? Where are they going to go? Well, we're going to need to draw another sulfur atom. Okay, so now we've got a sulfur atom with 6 valence electrons. We'll donate 1 electron here and 1 electron here. And now all the aluminums are going to be empty of electrons. Right? They'll have given away all their electrons. All the sulfurs are going to be full with electrons. Their outermost orbital is going to have 8 electrons in it. And so we can redraw the picture here. Here's the 2 aluminums, they're empty. Here's our 3 sulfurs, they're full with electrons, right? Each one got 2 blue electrons from those aluminum atoms. Okay, so then when we write our chemical formula, there should be 2 aluminums and 1, 2, 3 sulfurs, and that's what we see over here, Al2 and S3. Okay, one final example, magnesium nitride. So we'll start with magnesium. Magnesium is the second element in its row, so it gets 1, 2 electrons. And then we'll draw nitrogen. Nitrogen is the 1, 2, 3, 4, 5. It's the 5th element in its row, so it should get 1, 2, 3, 4, 5 valence electrons. Again, magnesium is the metal, so it's going to be the one donating electrons. So we'll donate 1 electron here and 1 electron here. Okay, but nitrogen still has 1 more spot available where it could accept an electron, so we need to draw another magnesium atom right here. And this magnesium atom will donate its electron. Perfect. Now this nitrogen is full, but now this magnesium atom still has 1 more electron left to donate. So we'll draw another nitrogen atom right here, and then this magnesium atom can donate. Perfect. Then we'll draw, now as we look at this nitrogen atom, we see that it still has 2 more spots left where it could accept electrons. So we'll draw 1 final magnesium atom right here. This electron will get donated right here, and this electron will get donated right here. Okay, and so then we are left with our final picture. We can see that all 3 magnesium atoms are empty, right? This magnesium atom lost 1, 2 electrons. This one lost 1, 2 electrons. This one lost 1, 2 electrons. And then these nitrogen atoms accepted 3 magnesium magnesium electrons, right? And we drew those in blue. Okay, so what does our final formula look like? Well, it should have 3 magnesium atoms, so Mg3, and 2 nitrogen atoms, so N2. We'll write it as Mg3 and N2. Hopefully this makes sense. If you have any questions, feel free to reach out to me or Ms. Buckle. Go ahead and work through the practice problems, follow the steps that we just went through, right? Draw the Lewis dot diagrams, figure out where the electrons are going to move to, and then write out the chemical formula. Okay, thanks.